Hello, grade 11 students. I am Teacher Vanessa of Sinunok National High School, Division of Misamis Occidental. Welcome to a new video lesson. Our topic is representations of functions. There are 5 ways to represent a function. Number 1, a set of ordered pairs. Number 2, mapping diagrams. Number 3, table of values. Number 4, graphs. Number 5, equations. Students, what are the 5 representations of functions? Number 1, set of ordered pairs. Number 2, mapping diagrams. Number 3, table of values. Number 4, graphs. Number 5, equations. Very good. At the end of this video lesson, we are expected to be able to describe relations and functions in different representations and to be able to determine whether a certain representation is a function or just a mere relation. Are you excited to learn about representations of functions? Well then, let us start. Functions and relations can be represented by a set of ordered pairs. How can we know if a set of ordered pairs represents a function or just a mere relation? A relation is a set of ordered pairs x and y, while a function is a set of ordered pairs x and y, such that no two ordered pairs have the same x value but different y values. For example, which of the following relations are functions? Letter A, letter B, letter C. Let's start with letter A. F equal to the set of ordered pairs containing 1 and 3, 4 and 1, 2 and 0, 7 and 2. A function is a set of ordered pairs x and y such that no two ordered pairs have the same x value but different y values. Let us check the x values of f. 1, 4, 2, and 7. No x values are the same. Thus, f is a function. Let's proceed to b. G equals to the set of ordered pairs 1 and 3, 2 and 5, 2 and 6, 3 and 7. Let us check if there are x values that repeat. 1, 2, 2, and 3. The x value 2 has y values 5 and 6. Therefore, there are ordered pairs with the same x values but different y values. Thus, f is not a function. It is just a mere relation. Letter C. F is equal to the set containing the ordered pairs 1 and 2, 2 and 2, 3 and 5, 4 and 5. Let us check the x values of f. 1, 2, 3, and 4. No x values are the same, or no two ordered pairs have the same x value. Thus, f is a function. Again, which of the following relations are functions? Letter A is a function. Letter B is just a mere relation. Letter C is also a function. Let's proceed to the second representation of function. Functions and relations can be represented by mapping diagrams. How will we know if the mapping diagram is a function or just a mere relation? Relations are also functions if each element in their domains have only one corresponding element in their ranges. For example, which of the following relations are functions? Let us have these mapping. The domain are the set containing the x, the range are the set containing the y. Let us discuss first this mapping diagram. This mapping diagram represents a one-to-one relation. One element in X is mapped to exactly one element in Y. Each element in the domain has only one corresponding element in the range. Clearly, 1 is mapped to 3, 2 is mapped to 5, 3 mapped to 9, 4 mapped to 17, and 5 mapped to 33. Thus, the map represents a function. Let's have the second diagram. This mapping diagram shows a many-to-one relation. Many elements in the domain are mapped in one element of the range. In order for this mapping diagram to be a function, it should satisfy the statement, each element in the domain has only one corresponding element in the range. Let us check. Element 5 is mapped to 1. Element 6 is mapped to 0. Element 7 is only mapped to 1. Element 8 is only mapped to 0. And 9 is mapped to only 1. It satisfies the statement. Thus, the map represents a function. Let's proceed to the last mapping diagram. This mapping diagram shows a one-to-many relation. One element in X is mapped to many elements in Y. Then, for this diagram to become a function, it should satisfy the statement, each element in the domain has only one corresponding element in the range. But element 7 is mapped to two elements in Y, 11 and 12. Element 2 in X is mapped to elements 13 and 14 in Y. Thus, the map is just a mere relation. Again, which of the following relations are functions? One-to-one relation is also a function. Many-to-one relation is also a function. But one-to-many relation is not a function, but just a mere relation. Let's proceed to the third representation of functions. Functions and relations can be represented by table of values. A table of values represents a function if there is no repetition of x values. Let's try this example. Which of the following relations are functions? Number 1 is a table of values containing the x elements 1, 2, 3, 4, and 5, and y elements 3, 5, 9, 17, and 33. Notice that there is no repetition of x values. Thus, the table of values represents a function. The second table is a table with x values 7, 7, 2, 2, and 1, and y values 11, 12, 13, 14, and 15. There is repetition of x values. Thus, the table of values is not a function, but just a mere relation. Again, which of the following relations are functions? The first table of values represents a function because there is no repetition of x values. The second table of values is just a mere relation because there are repetition of x values. The fourth representation of functions is graphs. Functions and relations can be described using graphs. We will use the vertical line test to determine whether the graph is a function or just a mere relation. The vertical line test says that a graph represents a function if and only if each vertical line intersects the graph at most once. For example, which of the following relations are functions? Graph 1 or graph 2? Let us check first graph 1. First, let us draw a vertical line. Clearly, the vertical line touches the graph twice. Thus, the graph doesn't represent a function. Let's proceed to graph 2. Again, let us draw a vertical line. The vertical line touches the graph once. Therefore, the graph represents a function. Which of the following relations are functions? Graph 1 is a mere relation. Graph 2 is a function. The fifth representation of functions is by equations. Functions and relations can be represented by equations. There are many types of equations, but let us just focus our discussion in these two common types. The linear function with the form y equals mx plus b, and the quadratic function with the form y equals ax squared plus bx plus c. Any equation with degree 1 or 2 transformable to a linear or a quadratic equation can be considered a function. Let us have this example. Suppose domains are the set of real numbers. Which of the following relations are functions? Number 1, y equals 2x plus 1. Number 2, y equals x squared minus 2x plus 2. Number 3, x squared plus y squared equals 5. Number 1 is a function, a linear function. Number 2 is also a function, a quadratic function. Number 3 is just a mere relation. Why is number 3 just a mere relation? We can find an x value that corresponds to more than one y value. For example, if x is equal to 1, then y is equal to either positive 2 or negative 2. And we are done. You have been very amazing. Congratulations! Now you have learned the representations of functions. Again, what are the 5 representations of functions? A set of ordered pairs, mapping diagrams, table of values, graphs, equations. Perfect! Now, get your paper and pen and start answering your LAS. So there you have our lesson for today. I hope you enjoyed watching the video and learned as well. Have a nice day. Goodbye!